Welcome to our presentation on CAM optimization. What is a Tebis solution for this? Well, Tebis is one integrated CAD, CAM, CAQ and MES package. We've got a lot of advanced toolpath strategies, which some of them quite unique to Tebis, and also increased CNC machining safety with our virtual machine technology. We have feature-based machining with open and closed data, and machining accuracy and surface quality is paramount for us. So again, excellent surface quality there. We can also increase your CNC machining efficiency with special cutters, special cutter support, and during the process of machining, you may want to check the quality of your parts, so that can be supported with our in-process measurement and probing with the quality control. So as I mentioned, Tebis also is integrated CAD, and the CAD is parametric associative. But all of these things that we've mentioned so far all add together to give us intelligent manufacturing, with all of your best practices built into the Tebis libraries. All of these things are put together to ensure consistent manufacturing process quality for you, reducing your programming difficulty and workload, and also your programming time, and reducing training periods for any new programming staff. So the aim is to reduce your work pressure and increase your productivity and ensure your delivery times. So how does this work? Well, intelligent manufacturing, this is about having your best practices built into Tebis software. So you can optimize and standardize your manufacturing processes, and we do this working together with you, the customer. Tebis has unique automation technology, including its virtual machines, cutting tools, features, and template machining cycles and processes, which are built into our 5 libraries. And all of these 5 libraries are your best practices, are you the customer, not Tebis's best practices, but yours. So all of these as well give you ease of use and short learning curves and consistent results. The intelligent processes as well can take into consideration color tables and layer information to give you different, maybe even different surface finishes. So maybe a hole with a H7 tolerance, or whether it's a threaded hole, or maybe it's just a surface that has a rough finish compared to a finished finish. All can be color coded. We have automatic selection of cutting tools for our machining processes and machining parameters, with also user-defined variables and conditional statements. Full automation on feature-based machining, including holes, with full variables on the features themselves and on the machining cycles which apply to them. And of course, all of these things can be optimized with tool changes and tilt directions. And finally, with full automation for predefined manufacturing processes to give you fast, efficient, consistent toolpaths. All of which should be optimized, because CAM programming is not just about fast programming, but also we want the optimization on your machine too for efficient toolpaths. So we talked about our 5 libraries previously. We had our virtual machines and clamping devices, as you can see. Our cutting tools, which is probably our most important library with all the cutting conditions stored in it. Our feature libraries and our machining cycles, which are attached to our features with variables, and our machining processes. Now all of these all link together, they all feed into the system to give you efficient, intelligent and safe CNC programs. So when we're working with our tooling library, why is this so important? Okay, so our cutting data that's stored with the cutting tool is very important because it gives us optimization over the material we're cutting and the machine we're cutting it from. And we're able to filter here the different types of cutting material that maybe your cutting tool is made from, whether it be solid carbide, whether it's an inserted cutter. But also we obviously can filter between the type of tool, whether it be a ball nose cutter, whether it be an end mill or torus cutter. And also then the machines should be considered, because maybe we have some old machines, maybe we have new machines. large machines, small machines. All of these things should be taken into consideration because each machine will have different cutting considerations as well. Following that, we can think about our processing group, whether it's a roughing operation, is it a finishing operation that we're doing, and what material are we cutting? Cast iron, aluminium, tooling board resins. And if we look at our list of materials here, you'll see that we've got your standard speeds and feeds and cutting cut per tooth as you would expect, but also we have far more advanced than most other systems with our technology for things like step over feed rates, our plunging feed rates, cornering feed rates, and plunging feed rates. That together with our optimal step overs with the AE values and our optimum step downs or depth of cuts with our AP values. Not forgetting the cooling option for that particular material that should be applied. So very, very advanced cutting conditions within the Tebis software. Our virtual machine technology also is very important to us. Our machine-orientated CAD programming, again, is unique to Tebis for CNC machining optimizations. In the previous slide with the cutting tools, I mentioned that we could have large machines, small machines, new machines, old machines for different cutting conditions. Each of these machines may have different rotational limits and linear limits. So in here we can use our virtual machines at 3 stages for planning, programming and verification, so 3 steps. And this gives a simulation for the collision check of tool changes, could be machine head changes. We have the full rest material tracking and collision checking. We support asymmetrical type heads, and you're able to interactively manually control the machine heads on these virtual machines too. With multiple setup, you can combine multiple CAD files and different parts which have been programmed by different people into one machining operation with optimized tool changes and tool tilt directions. And we also manage your tool links for safety checking. Many other softwares do not do this between the end of one toolpath and the start of another. We can control your machine macros, and the very end of all this is we're giving you full collision check avoidance of the complete machine, the spindle, the cutting tools, the tool holders and the part, etc. And finally, accurate machining times, because again we can build in all of your controller considerations into the virtual machine, such as your rapid rates, your look ahead, etc., to give you accurate machining times. To enhance our intelligent manufacture, we also have a clamping device library. This gives us simple positioning with components in the machine. Most people take clamping as a secondary option, and it's a secondary thought when it comes to machining. But as NC programmers, clamping is important to us, not only on the machine, but understanding where the clamp is in reality for collision checking. And we can manage these elements with a simple library in Tebis, or a very powerful library in Tebis, to position the part on the machine, or the clamp on the machine, position the part within the clamp, and collision check it with the jaws in its open or closed positions, simplifying your machine setup processes. And we're going to have a look at that in the demonstration following shortly. So what's the daily operation? How do we make our toolpaths optimize? How are these all intelligent? Because with our libraries make up our knowledge base. And when we import our data, we apply our knowledge base to that data, whether it be through the tooling, our clamping devices, and our features, machining cycles, and manufacturing processes. We can apply all these things, apply our manufacturing processes, and have good optimized standard NC code as an end result, and safe and efficient for your machines. So the daily operation with our CAD programming is not the hard work of CAD programming and making toolpaths anymore, but more a daily operation of organization. And we do this by putting our blank onto the correct part of our structure tree for the blank, again for our finished part, maybe our features and our clamping devices. And all of these used in our smart toolpath templates, our smart process templates and automation templates. So as a demonstration brief, we're going to show you how to optimize and how this can be optimized in the CAD CAM environment. And we're actually going to apply a smart process template to a component to demonstrate this, all using the 5 libraries we discussed. So onwards with the demonstration now, and what we can see is some example data on the screen with a blank and a clamping device. This is just example data for the templates that we're in. On the left hand side we have our process flow, and on our right we have our machining templates, our machining smart process templates. And what we'll do now is, first of all, we want to import some data which we want to machine. So first of all, I just go and select some data to import. And as you can see, quite quickly this data comes in. And you'll see that the part that I've imported is a completely different shape to what I've currently got, but the orientation is completely different too. So the first thing I need to do is orientate the clamping devices from my example to the new part. So first of all, we deal with the orientation. So the first thing is my origin, and align my X and Y axes. Like so. Now what we'll see is the structure tree update. You'll see the clamps update their orientation, and also the blank will update its orientation. So therefore, there as you can see, the clamps, as I said, have updated, also the blank. But also you may notice now we have 2 clamps because of the size of the block. Now what we need to do is exchange now the template data for the data which we actually want to machine, and we'll just select the data we want to machine now and apply this. And again, the structure will update with the blank and the clamping devices to the new data now. And there you see, we're now back to 1 clamp. We have our blank, which has been produced around the size of the model with some excess. And you'll see in here that the clamp has been applied not only with the right orientation, but to the right clamping position on the part. Now, maybe you don't want this sort of a clamp on this part. Maybe you wish to use something different. And as I mentioned in the presentation, we do have a clamping library. So we can choose from our clamping library what sort of clamps we want to use. And here you see we can easily exchange for some pull down clamps. Again, automatically adjusted to the size of the block. And maybe back again to the bench vise in this case. Also in the bench vise, you'll see that maybe we've only got a few millimeters of clamping area. Maybe we wish to increase this. Let's just increase to 10 millimeters, and you'll see the clamp update for the clamping area. Good. So that's our part setup. The next thing would be to look at applying features to this part. But before I do that, also with the orientation of this part and selecting the data, we've mentioned the blank has been updated, the clamping devices, but also, let's just have a look at the finished part. We have some cover faces too, which automatically have been applied to this. So all of this has been done through an automated means, and we can just maybe delete just the bits where we've overdone it. Good. And now our model will just update again. Good, so the model has now been updated. So the next stage is to apply our features. And remember, our features could be closed standard features for holes, pockets, slots, etc. But also open features for open faces. This is very important too. So we do this with our feature scan. And I can look at 3D, I can look at 1D, 2D or 3D data, and I can also check against the color table for these as well. So let's check for our bores, slots and rectangles, select the data, and in here now Tebis automatically matches these features in their different orientations to my library with variables in. If I click auto, they automatically get applied. So that's all of the holes. There's no slots. And we have some rectangular pockets. Let's just apply these. Okay, so that's been done. Now I have all of my features. And the last thing to do is organize them into the correct directions for machining. So quite simply, I use the sort, and these have now been organized for us. So let's just look now at how those have been sorted. You can see here I have the features at the bottom, the top, and the different directions around the job have been organized for us automatically. So now that we've done this, we can choose a smart process template to apply. And here we have one for components. And the first thing I do is apply the data from our structure tree to this smart process template. And now what we see under each of our process templates is our finished part data, but also a selection of toolpaths on the first setup and second setup, which will be automatically applied to the job. And it's worth remembering that these are not coded, scripted codes for templates. All of these are individual templates. If we don't need one, then it will just be bypassed and move on to the next one. It's not going to make your automation fail. So the next stage is let's set this up on the machine table where we want to machine this. And again, with the Tebis virtual machine technology, it's really important to understand that we can set this up where we want it on the machine bed, and we can plan and we can check against all the collision elements on the machine. You see the part now is in the position above this Matsura machine, and we can just decide now where on the machine bed do we want to go. And Tebis gives me some options. We want to select this area to the center of the table, like so. And the part now snaps into position. If I wanted to make some finer adjustments, that's all possible too. So now that we've done that, quite simply, we can now calculate our toolpaths. Because we've organized all of our data, we've orientated it, we've got our clamping devices, we've done our setup. So let's calculate these toolpaths now. And there we go. So let's just have a quick look under setup 1. We have our finished part. Maybe we can show our blanking and clamping devices, but the first toolpath has skimmed the job. We've roughed it. We've profiled and machined our features. And this one toolpath contains many toolpaths in here for drilling these holes. Let's just have a quick look into that. So now we see the part on the machine bed. And what we see now is all of our 2.5D machining operations. And there we go. Now let's look at setup 2, and we see here then that we've roughed the top of the job, we've roughed down the side of the part, we've finished the top. There's a toolpath here without a tick, so it wasn't required. And finally, so Tebis has skipped this one automatically for us, and we've machined all of our pockets, all of our holes from different directions with all optimized tool changes and cutting directions. And again, we can have a look at this. In our simulation, and yeah, you can see all of the tilt directions now are being applied. Good. So, in summary, from our demonstration on NC process optimization and CAM automation, Tebis, as we've mentioned before, is one integrated package for CAD, CAM, CAQ, and MES. It's virtual machine technology, it's integrated simulation with programming with virtual machine and post-processors are all linked, and can be used at 3 stages: our planning, our programming, and verification. We have intelligent manufacturers with best practices built into our libraries, with feature-based machining for closed and open datas, and high quality for surface quality and machining accuracy. All of these increase with our special cutter support for barrel tools, lens tools, etc. And also, if you wish, in-process probing and quality control as well can be applied. Together with our integrated parametric associative CAD, Tebis can reduce your workload pressure, it can increase your productivity with its optimized machining, and ensure your delivery times. Thank you for joining us.